We will go for the next part of the solution, that is the colligative properties. What is the meaning of colligative properties? It is the property of a non-volatile solution, means non-volatile solute present in a solution, which depend upon the amount or number of moles of solute present in it, which depend upon amount or number of moles of solute present in it. It is independent on the nature of solvent, it is independent on nature of solution, as well as it is independent on physical and chemical change of the solution. It only depends upon the amount or number of mole of solutes. Then we can say it has a colligative properties, and the factors which affect to the colligative properties of a non-volatile solution are: number one is the relative lowering of vapor pressure. Number two is the elevation in boiling point. Number three is the depression in freezing point. And number four is the osmotic pressure. So those are the factors which affect to the colligative properties of the solution, and how it is affected we'll go one by one. Before we'll go for those properties, first of all we'll know what is the relation of colligative properties with the Van-Schop factor. Already I told me about the Van-Schop factor. We know when I is equal to 1, then the solution is a non-electrolytic solution, and if I is equal to 1 and we want to detect the colligative properties of that solution, then I can say this is the normal colligative properties. And if I is not equal to 1 and we want to detect the colligative properties of those solution, then this becomes a abnormal colligative properties. And why it is normal and abnormal, when we will discuss one by one, then after I will tell. So we can say the normal colligative properties of the solution can be detected for non-electrolytic solution, whereas for the abnormal colligative properties of the solution can be detected for the electrolytic solution. And the main reason why it is called abnormal, because for the electrolytic solution we know, already I told, I is your calculated molecular mass by observed molecular mass. Like that you have written delta TF observation by delta TF calculation, that is also equal to delta TB observation by delta TB calculation, and that is equal to pi calculation by pi observation. In the last class already I told this thing also. So if I is not equal to 1, then M observation, that is the molecular mass observed, is not equal to molecular mass calculated, and for that reason this is called abnormal, and for that reason here I is most important. So when we go for the colligative properties of solution, first of all I will go for the relative lowering of vapor pressure. I told here we are just going to discuss the colligative properties of non-volatile solute present in the solution. Already I told, for the non-volatile solute in solution, the vapor pressure of solvent is greater than the vapor pressure of solution. Vapor pressure of solvent is greater than vapor pressure of solution. And in the non-volatile solute in solution, we are applying the Raoult's law. And already we have discussed, according to the Raoult's law for non-volatile solute in solution, P0 minus Ps by P0 is equal to mole fraction of solute. That is called relative lowering of vapor pressure. P0 minus Ps by P0 is called relative lowering of vapor pressure, and that is equal to mole fraction of solute. And this is for the normal colligative properties of the solution, means this is for the non-electrolytic solution. So here I is equal to 1. And if you take it for the electrolytic solution, so for electrolytic solution I can write the same equation. Electrolytic solution, the same equation can be written as P0 minus Ps by P0 is equal to I into mole fraction of solute. So that is for the electrolytic solution. And remember why it is called colligative properties, because the relative lowering of vapor pressure depend upon the mole fraction of solute, and we know mole fraction of solute is individual moles of solute by total moles. So that indicates that the relative lowering of vapor pressure depend upon the number of moles of solute. As it depend upon number of moles of solute, so it is a part of colligative properties. Remember one thing, The relative lowering of vapor pressure is a colligative properties, but if you go for the lowering of vapor pressure, it is not a colligative properties. Lowering of vapor pressure is nothing but the vapor pressure of solvent minus vapor pressure of solution. And we know whatever may be the amount you are adding, always the lowering of always the vapor pressure of solvent is greater than vapor pressure of solution. Always the vapor pressure of solvent is greater than the vapor pressure of solution, whatever may be the amount of non-volatile solute you are adding. And for that reason, we are telling lowering of vapor pressure is not a colligative properties, but relative lowering of vapor pressure is a colligative properties. Now I will go for the second part, that is the elevation in boiling point. So second part is the elevation in boiling point. So first of all, why its name is called elevation? Its name is called elevation because here boiling point increases. In between the solvent and solution, let's say you are taking the boiling point of solvent is T0 and the boiling point of solution is, let's say, Ts. So when you want to prepare a solution from the solvent, if the solute is non-volatile, that indicates its boiling point increases. And for that reason, how much increases? Its boiling point increases Ts minus T0. And that Ts minus T0 is called elevation in boiling point, can be written as delta Tb. So first of all, we should know what is the meaning of boiling point. Boiling point means it is the temperature at which vapor pressure is equal to atmospheric pressure. So boiling point is the temperature at which vapor pressure is equal to atmospheric pressure. Then we can say this is the boiling point. Remember, if I want to prepare a solution, let's say here I am taking water 100 ml under the atmospheric pressure 180. I am taking another container here. I am taking 100 ml water with 1 mole NaCl. And here I am taking another container with 100 ml water with 2 mole NaCl. Then I can say already we know the temperature is directly proportional to vapor pressure. I want to increase the vapor pressure here, I want to increase the vapor pressure here, I want to increase the vapor pressure here until it touches to 180, because this is the atmospheric pressure I have written here 180. Then the temperature required to increase vapor pressure more in this case, because here the amount of solute is more. So here if the 100 ml water I have taken, this is the pure solvent, if it gets the vapor pressure 180 at the temperature of 100 degrees Celsius, means I am telling by applying the temperature of 100 degrees Celsius, when the water reaches the temperature of 100 degrees Celsius, let the vapor pressure exerted from the water is 180, then I can say its boiling point is 100 degrees Celsius, because at this point its vapor pressure is equal to atmospheric pressure. Now here I have taken the 1 mole NaCl, and for that reason here the solute solvent interaction is more, and due to this reason here it requires more temperature than 100 degrees Celsius to make 1 atm as a vapor pressure. So here let's say the temperature required is 110 degrees Celsius to achieve the 1 atm vapor pressure. So I can say for this solution its boiling point is 110 degrees Celsius. And for this solution here the number of moles is again more, and for this solution it requires more temperature than 110 to achieve the vapor pressure 1 atm, and which is equal to the atmospheric pressure. Let's say here the temperature required is 115 degrees Celsius. So I can say at 115 degrees Celsius, let's say it achieved the vapor pressure 1 atm. So I can say its boiling point is 115 degrees Celsius. Now from the solvent to solution, when I want to prepare, the boiling point increases. This is 100 degrees Celsius to 110, and this is 100 degrees Celsius to 115. Now we can say if this is the container 1, this is the container 2, this is the container 3, and this is the boiling point of solvent, this is T0, this is the boiling point of solution, first solution, this is Ts, and this is the boiling point of second solution, Ts. Then what is the delta Tb I told? Delta Tb is your Ts minus T0, that is the boiling point of solution minus boiling point of solvent. And for the first container, second container if I want to take, then what is the elevation in boiling point? that is the 110 minus 100 degree. So that is your 10 degrees Celsius. But for the first container with respect to the third container, what is the elevation in boiling point? The elevation in boiling point for the first with third container is your 115 degrees Celsius minus 100 degrees Celsius. So that is your how much? 15 degrees Celsius. So I can say the elevation in boiling point with respect to third container is more than the second container. Why? Because the amount of solute is more. As a result, we can say the elevation in boiling point is also a colligative properties. Remember, here I am taking the temperature difference. The temperature difference in degrees Celsius and temperature difference in Kelvin are equal. That means I am telling 10 degrees Celsius here is equal to 10 Kelvin. 15 degrees Celsius is also equal to 15 Kelvin. Now, why is it? Because let's say you are taking T0 is let's say 10 degrees Celsius. Then if I want to make it Kelvin, then it becomes 283 Kelvin. Just add 273. If Ts is 14 degrees Celsius and I want to make it in Kelvin, then it will be 287 Kelvin. Then what is the difference? Ts minus T0 in degrees Celsius is also 4 degrees Celsius and in Kelvin also 4 Kelvin. So temperature difference in degrees Celsius and degree Kelvin are always equal. Now I told how to calculate the delta Tp. On the next class I will tell how it is related to the molality.